Hello again, welcome to the final, and by that I mean final PowerPoint presentation for this course, where we will finish going over a few more functional groups in organic chemistry. Now I did haloalkanes and alcohols in a little bit more detail than I will do these. I just want you to be able to identify these and know some common types. First, let's do ethers. Ethers are compounds in which oxygen is bonded to two carbons. So it's like an alcohol where the hydrogen has been replaced by another hydrocarbon group. So to name, the alkyl groups on each side of the ROR are named in alphabetical order. So if I have CH3, CH2O, CH3, that is an ethyl on the left and a methyl on the right. Left, right doesn't matter. E comes before M, so that is called ethyl methyl ether. If both sides have the same alkyl group, you use the prefix di. So if they're both methyl, it becomes dimethyl ether. Now there are other ways of naming these, but that is the method that I'm teaching you. So you have ethyl methyl ether and dimethyl ether. Ethyl ether is an excellent solvent, for example. So what are these used for? There are a wide variety of chemical reactions. By extraction, it's a way of separating materials. So I have a liquid, and ether is itself not soluble in that liquid. So it forms a layer, and some things will dissolve into the ether out of the other liquid. And that's an extraction where you're separating stuff by insolubilities of two liquids, but a differential solubility of a solid. So it's like a way of taking something out of something else. It's also used as a volatile. Volatile means that it evaporates very easily, but it's used as a volatile starting fluid for diesel engines in cold weather. So just spray a little bit of that in there and and it gets into the system and allows you to start it up when the gasoline doesn't want to start quite flowing yet. Dimethyl ether is also used as a spray propellant and refrigerant. I believe this is what was used when I broke my finger really badly. Sorry, I can't show you in video. One of these days I'll have to get some green screen so I can narrate these properly. But broke my finger once, and they had to like basically spray freeze it to reset it. They just basically sprayed the solution on there and took a pair of pliers and pulled my finger out and put it back in where it went. But it can be used as kind of a quick refrigerant. So that's all I want you to know about ether. It's really easy to name. You just name the two sides and put ether on the end. Now, aldehydes and ketones are another special group. Remember, an alcohol is an oxygen bonded by a single covalent bond. So you have a single covalent carbon oxygen. But if you have a double covalent bond, then it becomes either an aldehyde or a ketone. Okay? And that is a C double bonded O. At the end, it's an aldehyde. In the middle, it's a ketone. So what do we know about these? What are their properties? Well, there's a weak hydrogen bonding between the oxygen of the aldehyde or ketone and water oxygen. So they do have a little bit of hydrogen bonding because of that oxygen. They're exposed with the unbounded electrons exposed. Lower members, meaning those with less carbons, are soluble in water, but as the length of the carbon chains increases, so does the solubility, just like alcohols. They are all soluble in non-polar solvents, though, so they are all soluble in water. I mean, not water, in oils. They have lower boiling points than alcohols, but still higher than alkanes. So having that OH at the end raises the boiling point more. Now, what are they used for? The most important one that you'll note might be formaldehyde, which is actually methanal. So the common name is formaldehyde, but technically it's methanal. So how do you name aldehydes? You basically put an AL at the end. So instead of it being methane, it becomes methanal, AL. Now, if it was a longer chain hydrocarbon and you needed to identify the carbon on which the a double bonded O was attached to, you would put a number. But since it's Al, you know it's always at the end, so there's no number. It'd be methanal, propanal, ethanal, butanal, pentanal. That means that it's an aldehyde. If it's an ONE ending, that's for a ketone. And ketones do need a number if there's more than 2 carbons, or more than 3 carbons. Because propanone, since it's an ONE, it cannot be at the end, and there's only 1 carbon in the middle of a 3-chain carbon. So you do not need a number there. You could call it 2-propanone, but you don't have to. Technically, butanone doesn't need a number either because it would always be 2-butanone. But if there were other constituents there, then it could change, substituents, then it could change it. But basically, you put a number for an aldehyde, you end it in Al. For a ketone, you end it in ONE. And if it's more than 4 carbons long, you have to use, or more than 3 carbons long, sorry, you have to put a number to tell you where it is. So acetone, which is also propanone, that's the proper name, propane, 3 carbons long, ONE, there's a double bonded oxygen, propanone. Also known as acetone, that's very valuable. We use it in a lot of stuff. It's used in fingernail polish remover. It's very useful because it dissolves a lot of stuff. It dissolves both polar and nonpolar. It's like a wonderful solvent for so many things. And something that's also soluble in it is super glue. So if you ever get super glue on yourself, just go find some fingernail polish remover, and that'll remove it off. Now, the problem with fingernail polish is that it kind of gets oily because of all the other perfumes and stuff that they add to it to make it not smell bad. If you can get pure like acetone, which you can buy at Walgreens and stores like that, that's better for removing something like super glue, because then you don't have to keep washing off the oily residues that form. So naming again, for aldehydes, you use the longest hydrocarbon name and just replace the final E with an Al. So if it's 2 carbons long, it becomes ethanal. Now this is also known as acetaldehyde. Now notice how I didn't draw it out. I just wrote CHO. CHO is a shorthand method to write the end of an aldehyde. If I had written it as COH or CHOH, then it's an alcohol. So OH means hydroxyl, HO means a double bonded O group. Now if it's a ketone, you change the name of the longest continuous carbon chain to, instead of ending in E, to ending in ONE, O-N-E. So here I have a 4 carbon chain, CH3, CH2, CO, CH3. If I number it from the right, the second carbon has that double bonded O. So it's 2-butane because it's 4 long, but I changed the E to an O-N-E, so 2-butanone. So if it's an aldehyde, you get an Al ending. If it's a ketone, you get an O-N-E ending and a number. Those are the only added rules for naming aldehydes and ketones. Now carboxylic acid, I don't think I mentioned it before, but that C double bonded to O, that functional group is called a carbonyl group. And I already mentioned that OH is a hydroxyl group. If you have both a carbonyl and a hydroxyl, it loses its alcohol behaviors and actually gets acidic behaviors. Now I can't really draw it out here. There's actually a resonance that occurs where that hydrogen is sort of shared by both of those oxygens, and it basically creates a situation where that hydrogen is very easy to release. It's very reactive and making it acidic. But that is a carboxylic acid, and it can be written as COOH is how you write a carboxylic acid. So for instance, if I have CH3, CH2, COOH, that is 3 carbons long, so it would be propane. But the way you name a carboxylic acid is you change the name to oic acid. So that would be propanoic acid. If it was 2 carbons, it would be ethanoic acid. Now that actually has a common name, acetic acid, which you may also know as the main component of vinegar. So these things exist in nature very commonly. The most common place that you see carboxylic acids, or not necessarily that you see, but one of the most important carboxylic acids is deoxyribonucleic acid. DNA is a long chain of carboxylic acids that have been joined. Now they also have nitrogen containing groups, so it's more than just a carboxylic acid, but they have they have a carbonyl and a hydroxyl group or a carboxylic acid group on them. So if I have a carbonyl, C double bonded O, and a hydroxyl, we now call that a carboxyl. So you can have a carbonyl group, a hydroxyl group, or a carboxyl group when you have both of them. Esters are derivatives of carboxylic acids in which that OH group on the end is now an OR group. So you now have a carbonyl group and an alkyl or aryl group. All right, so these are esters. C-O-O-R instead of C-O-O-H. These are polar unless the hydrocarbon chains get long. As the hydrocarbon chains get longer and longer, they lose their polar behavior, as is common for these things, organic molecules. But even though they are polar, they do not form hydrogen bonds because, as you can see, those 2 oxygens don't have a hydrogen bound to them. These have low boiling points, so it's very easy to melt them or to boil them. In fact, they're usually gases. The smaller chain ones are gaseous, and they are also very nice smelling. And these are found naturally in fruits, and they're one of the things that give fruits the nice odor. So there's a little bit of ester in fruit that gives it a nice odor that tells you, oh, there's other good stuff here for you to eat. I'm not going to make you name these. I just want you to be able to identify esters. But they're basically named the same way as ethers, where you name each side, but there are rules, conventions for the order and all that stuff. You're welcome to look it up if you're interested. So we come back to our main slide. We've talked about the hydrocarbons before. In this chapter, we've talked about alcohols, ethers, aldehydes, ketones, carboxylic acids, and haloalkanes. Now, while I won't, and we talked about esters. Now, while I won't go into them, if we would have had time to test on this, I would have also expected you to be able to identify amide, amine, and thiol. The amide, amine, those AM, that means that there is a nitrogen group. And if it is an amide group attached to a carbonyl group, it's an amide. And if there's no carbonyl group, it's an amine. And then just like there's an alcohol when it's OH, there's a thiol when it's SH. And these are very common. They have lots of chemistry, right? All I'm going to get into is how to identify them for you guys. And that basically concludes what I was hoping to teach you guys. Just basics of organic chemistry. I hope you found it a little bit interesting to be able to identify what these things actually mean when you hear the word ether, ester, and just to know how common these are in nature and that they have a lot of really good uses.